Story of life on Earth is written in the rocks. Paleontologists have worked tirelessly to piece together the tangible historical evidence for evolution, which is the fossil record. Fossils have been known since ancient times. Aristotle discussed them, and fossils of the beaked dinosaur Protoceratops may have given rise to the mythological griffin of the ancient Greeks. Let me explain how fossils are made. First, the remains of an animal or plant must find their way into water, sink into the bottom, and get quickly covered by sediments so that they don't decay. Once buried safely in the sediments, the hard parts of fossils become infiltrated or replaced by dissolved minerals. Once a fossil is formed, it has to survive the endless shifting, folding, heating, and crushing of the Earth's crust. Then it must be discovered. The fossil record is incomplete. Estimation of only 0.1% to 1% of all species have been found. Because fossils occur in sedimentary rocks that begin as silt in oceans, rivers, or lakes, the deeper layers or strata must have been laid down before the shallower ones. Younger rocks live on top of older ones. If a layer of the same type of rock containing the same type of fossil appear in two different places, it's reasonable to assume that the layer is of the same age in both locations. This is called the principle of superposition. Using radioactivity, we can measure the actual ages of some rocks. Certain radioactive elements called radioisotopes are incorporated into igneous rocks when they crystallize of molten rock from beneath the Earth's surface. If we know the half-life, which is the time required for half of the isotope to disappear, it is simple to estimate the age of the rock. Different isotopes decay at different rates. Old rocks are often dated using uranium-238 found in the common mineral zircon, and it has a half-life of about 700 million years. Carbon-14 has a half-life of 5,730 years and is used for much younger rocks.
What constitute evidence for evolution in the fossil record? A scan through the entire sequence of rock strata would show early life to be simple and over time become more complex. Using a fossil record, we would be able to see how animals and plants evolved from a common ancestor and later split into a new species. An example would be, in the 19th century, anatomists predicted that mammals evolved from reptiles. If so, we would be able to see evidence from the fossil record. By putting the strata in order and estimating their dates, we can organize a fossil record from oldest to most recent. The strata is a timeline of life's history on Earth. It provides evidence of when the first organisms appeared during the Archean era to the first primates in the Cenozoic era. In addition, the strata helps us see how organisms evolved from simple to more complex organisms. No theory other than evolution can help explain these patterns. Evolution can be gradual and punctuated. When its gradual evolution occurs where the increment of change is small compared to that of time. When it is punctuated, evolution occurs where the increment of change is rapid compared to that of time, while most of the time it might have no change. An example of uneven evolution is a irregular pattern of the pseudocubus Vima's thorax size. The graph shows that the size of the thorax sometimes experiences a period of stasis followed by abrupt changes. These irregular patterns are due to environmental influences. As Cohen said, forms of life appear in the record in evolutionary sequence and then evolve and split. Lastly, we need transitional species that show a mix of traits from organisms that lived both before and after it. By finding these intermediates, it will help fill in the missing links.
One of the greatest predictions made using evolutionary theory and the concept of missing links is that of Tiktaalik-Rosier. In 2004, researcher Neil Shubin was determined to understand the evolution of limbs from fins. Using the concept of superpositioning, Shubin found sediments of the right age and zeroed in on the unexplored region in the Canadian Arctic. Shubin found the elusive missing link sticking out of a rock. When extracted, it had all the necessary features, including gills, scales, fins, a neck, and features of amphibians like flat head, a neck, and eyes and nostrils on the top and not on the sides of the skull, meaning it could peer above the water and even breathe with the help of robust fins, allowing it to flex upward to help survey surrounding areas. Most importantly, sturdy ribs helped it pump air into its lungs and had fewer sturdy bones than its lobe-finned fish ancestors. All of these traits provide considerable evidence linking amphibians to fish ancestry. We can also hypothesize what could have given rise to the flight character state, and birds for that matter. Biologists believe that birds came from reptile ancestors, but then what pressure was put on them to evoke such a change, and what kind of transitional forms could exist? The flying squirrel, for example, found use in being able to glide from predators in trees and move around with ease. Since we see carnivorous birds 200 million years ago and the more modern birds 70 million years ago, then we should be able to hypothesize of transitional intermediates that fill the gap somewhere in the fossil record. Perhaps the most important common ancestor to birds and reptiles was Archaeopteryx lithographica, found in Germany in the 1860s and lands right in that predicted time span at 175 million years ago. Archaeopteryx had bird-like traits, one being its opposable big toe for perching and the other being its feathers. Still unclear whether it could fly and whether its feathers evolved as an ornament or to buffer flight. We can debate the specifics, but the existence of transitional fossils and the evolution of birds from reptiles is fact. Other transitional forms show the evolution of marine life evolving to terrestrial tetrapods and back to the water, as seen from intermediates of hippos to whales. The fossil record teaches us three things. 1, confirms predictions and shows gradual change within lineages. 2, the transitional forms appear precisely the way where they should. And 3, there is no reason why a celestial being would refashion old traits into new ones. It's for all these reasons we accept the author's point, based on irrefutable evidence that in the fossil record that evolution is occurring.